The National Electrical Code, Section 210.25a, addresses the electrical requirements for dwelling units, clarifying the need for separate load centers or panel boards. This section stipulates that each dwelling unit must have its own dedicated load center or panel board. This panel board must supply all the outlets and lighting within that specific dwelling unit. This requirement ensures that each suite functions electrically as an independent entity, simplifying troubleshooting and preventing electrical issues in one suite from affecting others. The code also mandates that the load center or panel board be located in an accessible location within the dwelling unit. This accessibility is crucial for maintenance, repairs, and electrical inspections. If the panel board is easily accessible, electricians can quickly address any electrical problems, reducing downtime and improving safety. However, there is an exception to this rule. A single load center or panel board may serve more than one dwelling unit if it is necessary to accommodate service equipment, busways, or other approved equipment. This exception recognizes that in some situations, it may be impractical or impossible to provide a separate panel board for each dwelling unit. For example, in a large building with limited space for electrical equipment, it may be more efficient to use a single panel board to serve multiple units. Similarly, if the building uses a busway distribution system, it may be necessary to connect multiple dwelling units to the same busway. In practical terms, the application of this code section means that when designing the electrical system, each hotel suite, if considered a dwelling unit, must have its own panel board. This panel board should be sized to accommodate the anticipated electrical load of the suite, including lighting, appliances, and receptacles. The location of the panel board should be carefully considered to ensure that it is accessible to both residents and maintenance personnel. If it is not feasible to provide a separate panel board for each suite, the exception may be invoked, but it is important to document the reasons for doing so and to ensure that the shared panel board is adequately sized and protected. Some additional considerations are: 1. Load calculations must be performed for each dwelling unit to determine the appropriate size of the panel board and the feeder conductors. 2. Overcurrent protection devices, such as circuit breakers or fuses, must be provided to protect the branch circuits and feeders. 3. All electrical work must be performed by qualified electricians and must comply with all applicable codes and regulations. Understanding and adhering to these code requirements is essential for ensuring the safety and reliability of the electrical system. Failure to comply with these requirements can result in electrical hazards, equipment damage, and code violations. Always consult with a qualified electrical engineer or electrician to ensure that electrical installations meet all applicable codes and standards. For dwelling units, National Electrical Code Article 210.25 specifically states that each dwelling unit shall have a separate load center or panel board supplying all outlets and lighting within the dwelling unit. The load center or panel board shall be located in an accessible location within the dwelling unit. This requirement is in place for several reasons, including safety, convenience, and maintenance. Firstly, safety is paramount. Having a separate panel board for each dwelling unit ensures that electrical faults in one unit do not affect other units. This isolation minimizes the risk of electrical fires and other hazards. Secondly, convenience is enhanced. Residents can easily control and manage their own electrical circuits without affecting their neighbors. This independence is particularly important in multi-unit dwellings where residents may have different electrical needs and usage patterns. Thirdly, maintenance is simplified. When electrical problems arise, technicians can quickly identify and isolate the issue to the specific dwelling unit without disrupting power to other units. This targeted approach reduces downtime and minimizes inconvenience for residents. There is an exception. Where necessary to accommodate service equipment, busways, or other approved equipment, a single load center or panel board may serve more than one dwelling unit. This exception recognizes that there may be situations where it is impractical or impossible to provide a separate panel board for each unit. For example, in older buildings with limited space or in buildings with complex electrical distribution systems, sharing a panel board may be the only feasible option. Even when this exception is applied, several precautions must be taken to ensure safety and convenience. Firstly, the shared panel board must be adequately sized to handle the combined electrical load of all the dwelling units it serves. Secondly, each dwelling unit must have its own set of overcurrent protection devices, circuit breakers or fuses to protect its individual circuits. Thirdly, the panel board must be readily accessible to all residents or maintenance personnel. When designing electrical systems, it is essential to carefully consider these requirements and exceptions to ensure compliance with the National Electrical Code and to provide a safe and reliable electrical system for all occupants. It is also advisable to consult with a qualified electrical engineer or inspector to ensure that all installations meet the latest code requirements and best practices. Consider specific scenarios for clarity. Imagine a hotel with individual suites, each designed as a full kitchen. According to NEC 210.25a, each suite should have its own dedicated load center or panel board. This panel board would supply all the outlets and lighting within the suite, ensuring that each unit operates independently from an electrical standpoint. The panel board must be located in an accessible area within the suite, such as a closet or utility area, allowing for easy maintenance and troubleshooting. Now, let's consider a situation where the hotel is an older building with limited space for electrical equipment. In this case, the exception to NEC 210.25 might apply. It may be necessary to have a single load center or panel board serve multiple suites due to space constraints. However, even if this exception is used, it is crucial to ensure that each suite has its own set of circuit breakers within the shared panel board. This setup allows each suite to have its own overcurrent protection and prevents electrical faults in one suite from affecting others. The shared panel board must be adequately sized to handle the combined electrical load of all the suites it serves. Load calculations must be performed to determine the appropriate size of the panel board and the feeder conductors that supply power to it. Furthermore, the panel board must be readily accessible to all residents or maintenance personnel. In another scenario, imagine a new hotel being constructed with a modern electrical distribution system. The design includes a busway system that runs throughout the building. In this case, the exception to NEC 210.25 might also apply. It may be more efficient to connect multiple suites to the same busway rather than providing a separate panel board for each unit. However, even with the busway system, it is still necessary to ensure that each suite has its own set of overcurrent protection devices. This can be accomplished by installing tap boxes at each suite that contain circuit breakers or fuses. The tap boxes would connect the suite's electrical system to the busway and provide overcurrent protection for the individual circuits within the suite. These scenarios highlight the importance of understanding the requirements of NEC 210.25 and its exceptions. When designing electrical systems for multi-unit dwellings, it is essential to carefully consider the specific circumstances and to consult with a qualified electrical engineer or inspector to ensure compliance with the code. Another crucial factor to consider is the type of appliances and equipment that will be used in each suite. If the suites are equipped with high-demand appliances such as electric ranges, ovens, and air conditioners, the electrical load will be significantly higher. In such cases, it is even more important to ensure that each suite has its own dedicated panel board and that the panel board is adequately sized to handle the load. Failure to properly size the panel board can result in overloaded circuits, nuisance tripping of circuit breakers, and even electrical fires. It is also important to consider the potential for future expansion. If there is a possibility that the suites will be renovated or upgraded in the future, it is wise to install a larger panel board than is currently needed. This will provide the flexibility to add additional circuits and appliances without having to replace the entire panel board. Furthermore, it is important to use high-quality electrical equipment and materials. Cheap or substandard equipment can be unreliable and even dangerous. Always use equipment that is listed by a recognized testing laboratory, such as Underwriters Laboratories UL, and that is suitable for the intended application. Proper grounding is also essential for electrical safety. The grounding system must be installed in accordance with the requirements of the National Electrical Code, and it must be properly maintained. A properly grounded electrical system helps to protect against electrical shock and reduces the risk of electrical fires. Regular inspections and maintenance are also crucial for ensuring the continued safety and reliability of the electrical system. The electrical system should be inspected periodically by a qualified electrician to identify any potential problems. Any necessary repairs or replacements should be made promptly. By following these guidelines, you can ensure that the electrical systems in the hotel suites are safe, reliable, and compliant with all applicable codes and regulations. This will help to protect the residents and staff of the hotel and to prevent costly electrical problems. In summary, while NEC 210.25 generally requires each dwelling unit to have its own separate load center or panel board, there are exceptions that may apply in certain situations. It is essential to carefully consider the specific circumstances and to consult with a qualified electrical engineer or inspector to determine the most appropriate solution. The primary goal is to ensure the safety and reliability of the electrical system for all occupants. Load calculations are a fundamental aspect of electrical design, especially when dealing with dwelling units like hotel suites with full kitchens. These calculations determine the appropriate size of the electrical service, panel boards, feeders, and branch circuits to safely and efficiently supply power to the intended loads. Accurate load calculations prevent overloading, voltage drops, and potential hazards such as overheating and electrical fires. Firstly, the general lighting load must be calculated. This is typically based on the square footage of the dwelling unit. The National Electrical Code provides guidelines for determining the minimum lighting load requirements per square foot. Secondly, the small appliance branch circuit load needs consideration. Each dwelling unit is required to have at least two 20-amp small appliance branch circuits to serve countertop receptacles in the kitchen, pantry, and dining areas. A load of 1500 volt amps is typically used for each of these circuits. Thirdly, the laundry circuit load must be factored. Each dwelling unit must have at least one 20-amp laundry circuit. Again, a load of 1500 volt amps is typically used for this circuit. Fourthly, the individual appliance loads must be included. This includes the loads of all fixed appliances such as refrigerators, dishwashers, ranges, ovens, and microwave ovens. The nameplate rating of each appliance should be used to determine its volt amp load. Fifthly, the heating, ventilation, and air conditioning, or HVAC, load must be calculated. The load of the HVAC system can be significant, especially in climates with extreme temperatures. The nameplate rating of the HVAC equipment should be used to determine its volt amp load. After calculating all of the individual loads, the next step is to apply demand factors. Demand factors are percentages that are applied to the total calculated load to account for the fact that not all loads will be operating simultaneously. The National Electrical Code provides demand factors for various types of loads, including lighting, appliances, and HVAC equipment. Applying demand factors can significantly reduce the overall calculated load, which can result in smaller and less expensive electrical equipment. After applying demand factors, the final step is to determine the size of the electrical service, panel boards, feeders, and branch circuits. This is done by dividing the total calculated load by the voltage of the electrical system to determine the current. The size of the conductors and overcurrent protection devices must be selected to safely carry the calculated current. It is essential to use the appropriate tables and guidelines in the National Electrical Code to ensure that the conductors and overcurrent protection devices are properly sized. These calculations are best performed by a qualified electrical engineer or electrician. They have the knowledge and experience to accurately calculate the loads and to select the appropriate electrical equipment. Proper load calculations are essential for ensuring the safety and reliability of electrical systems in hotel suites with full kitchens. It is important to follow the guidelines in the National Electrical Code and to consult with a qualified professional to ensure that the electrical system is properly designed and installed. Overcurrent protection is a critical safety feature in electrical systems, designed to protect conductors and equipment from damage caused by excessive current flow. Overcurrent can result from various factors, including short circuits, overloads, and ground faults. Without adequate overcurrent protection, these conditions can lead to overheating, insulation breakdown, electrical fires, and equipment failure. The two primary types of overcurrent protection devices are circuit breakers and fuses. Circuit breakers are electromechanical devices that automatically interrupt the flow of current when an overcurrent condition is detected. They can be reset and reused after the fault has been cleared. Fuses are one-time devices that contain a fusible link that melts and breaks the circuit when an overcurrent condition occurs. Fuses must be replaced after they have blown. The selection of the appropriate overcurrent protection device depends on several factors, including the voltage and current rating of the circuit, the type of load being protected, and the interrupting rating of the device. The interrupting rating is the maximum amount of fault current that the device can safely interrupt without failing. It is essential to select an overcurrent protection device with an interrupting rating that is high enough to handle the potential fault current at the point of installation. The National Electrical Code provides detailed guidelines for selecting and installing overcurrent protection devices. The code specifies the maximum allowable overcurrent protection for various types of conductors and equipment. It also requires that overcurrent protection devices be readily accessible and that they be clearly marked to indicate their ampere rating. In dwelling units, such as hotel suites with full kitchens, overcurrent protection is required for all branch circuits and feeders. Branch circuits are the circuits that supply power to individual outlets and appliances. Feeders are the circuits that supply power to panel boards. The overcurrent protection for branch circuits is typically provided by circuit breakers or fuses installed in the panel board. The size of the overcurrent protection device is determined by the ampacity of the branch circuit conductors. The ampacity is the maximum amount of current that a conductor can safely carry without overheating. The National Electrical Code provides tables that list the ampacities of various types of conductors based on their size, insulation type, and installation method. It is essential to select conductors and overcurrent protection devices that are properly sized to prevent overheating and to ensure the safety of the electrical system. In addition to protecting conductors and equipment from overcurrent protection devices also play a role in protecting people from electrical shock. Ground fault circuit interrupters, or GFCIs, are special types of circuit breakers that are designed to protect against ground faults. A ground fault occurs when current flows through an unintended path to ground, such as through a person's body. GFCIs detect ground faults and quickly interrupt the flow of current, preventing electrical shock. The National Electrical Code requires GFCIs in certain locations where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. Proper overcurrent protection is essential for ensuring the safety and reliability of electrical systems in hotel suites with full kitchens. It is important to follow the guidelines in the National Electrical Code and to consult with a qualified electrical engineer or electrician to ensure that the overcurrent protection system is properly designed and installed. Regular testing and maintenance of overcurrent protection devices are also important to ensure that they are functioning properly. Circuit breakers should be tested periodically to ensure that they trip properly under overcurrent conditions. Fuses should be inspected to ensure that they are not damaged or corroded. Any faulty or damaged overcurrent protection devices should be replaced immediately. By following these guidelines, you can ensure that the overcurrent protection system in the hotel suites is providing adequate protection against overcurrent and electrical shock. This will help to protect the residents and staff of the hotel and to prevent costly electrical problems.